Necessity, they say, is the mother of invention. We have a lot of necessity in our society today. And I think the time is here for inventing new approaches, new solutions to these various problems, so that we can indeed maintain America, and indeed the rest of the world as well, as the land of opportunity for all of those who will be the achievers of the future. Thanks very much.
Before the days of modern computing, the concept of using machines to perform mathematical calculations was still in its infancy and unknown to most people. The first known analog computer, the abacus, was developed over 4,000 years ago and was used for simple arithmetic, though carrying large amounts of disadvantages and weaknesses. As time passed, new devices were developed to perform increasingly complex calculations, learning from the previous. The astroblade, the slide rule, and the mechanical calculator all played important roles in the evolution of computing. During the World Wars in the early 20th century, the first electronic computers were developed and handled purely for military operations. The Adonisov Berry computer, the Harvard Mark I, and the ENIAC, the first electric general-purpose computer, were all groundbreaking machines that paved the way for the modern computer. However, these were massive and would take up entire rooms for relatively slow speeds. All the instruments mentioned had one of two flaws. Either it was very simple and slow, or it was massive and took up too many resources. A compromise and innovation needed to arise. This came with the arrival of the Intel 4004, marking the beginning of a new era in computing. One that would see rapid advancements in technology and the miniaturization of computers, making them more accessible and affordable. In the late 1960s, the Japanese company Busicom approached the newly founded Intel Corporation with a request for a set of custom chips to be used in their new line of calculators. Intel, at the time purely a memory chip manufacturer, saw an opportunity to build a general-purpose chip that could be used in multiple devices, and assigned a team led by Federico Fagan to the project. Fagan, an engineer and physicist, came up with the revolutionary idea of integrating all the components of a computer's central processing unit, or the CPU, onto a single piece of silicon, which greatly reduced the size and cost of electric devices that incorporated the chip. This was a major breakthrough in the design of electric devices. After months of hard work, the team succeeded in creating the first commercially available microprocessor, the Intel 4004, which was released in 1971. The chip was originally intended for use in calculators, but it was soon recognized for its potential use in a wide range of applications, including personal computers and embedded systems. The 4004 had a processing power of approximately 0.06 million instructions per second and was capable of addressing up to 640 bytes of memory. It was also the first microprocessor that was produced using an NMOS process, which made it more power efficient and reliable than previous designs. This invention of the 4004 marked the beginning of a new era in the world of electronics, making it possible for smaller, more powerful, and less expensive devices to be developed, and bringing the power of computing to the masses. We interviewed James, who works at Intel.
Okay, so we're talking about the Intel 4004 chip that we see here. It's the first general-purpose microprocessor. Originally, Intel was given $60,000 to produce 12 chips for the Busicom calculator by the Nippon Machine Corporation. They thought at the time you would need 12 chips to power this calculator. And Intel decided that basically we started out as a memory company, not a microprocessor company. So we actually developed the 4004 general purpose microchip with the 2300 transistors. And we shrank it down. Instead of 12, we used 4. There's one ROM, and then 2 RAMs, and then a printer interface and the microprocessor. So basically, the ROM, read-only memory, And I don't know if you're familiar with read-only or random access memory. Read-only is like when you're first born, you breathe. You don't have to think about breathing, you just do it. That's basically what RAM is. RAM is like algebra. You'll be taught algebra, and when you grow up, you'll realize you don't know how to do any more algebra that you were taught. But you can relearn it, and that's random access memory. So it uses the memory in the RAM and ROMs to the processor to tell the calculator how to function.
Okay.
So basically, it took all the information from the RAM ROMs and the input of the person that was using a calculator to print out the calculator. So you're having the input and the output. The input is from the user, the output is basically through the processor, and it uses the RAM and ROMs to know how to process all of the inputs for your output.
The Intel 4004 was developed at over a cost of $60,000, $440,000 in today's money, making it a significant investment for any business looking to incorporate the chip into their products. But despite the high costs, the 4004 was integrated into a plethora of devices, from calculators and watches to traffic lights and vending machines. It was used as a simple microcontroller and saved companies time and money designing specific chips for their products. The Intel 4004 itself cost $60 or $440 in today's money, but the high cost of the 4004 didn't last long. As the demand for microprocessors grew, so did the competition among chip manufacturers, most notably the rise of their rival to this day, AMD. This led to a decrease in cost and an increase in performance, making the technology more accessible to a wider range of businesses and consumers. The success of the 4004 paved the way for future advancements in chip technology. The development of smaller and more affordable microprocessors allowed for the creation of increasingly powerful and compact devices. From smartphones to laptops, the technology that began with the Intel 4004 can now be found in nearly every aspect of our daily lives. The Intel 4004 may have been expensive at the time of its release, but its impact on the technology industry cannot be overstated. It was the first step in a journey that will lead to the miniaturization and the democratization of computing power. And for that, we have the Intel 4004 to thank. We interviewed Dak Spicer, who's been working at the Computer History Museum for over 30 years.
Okay. Final question. How does the legacy of the 4004 continue to influence technology today?
Stay with me here. The 4004 led to the 8008, which led to the 8080, which led to the 8086. So 3 generations away from the 4004 came this chip called the 8086. That was the chip that IBM chose for its IBM PC. That was a huge win for Intel and made them billions of dollars, and IBM billions of dollars, of course. But what it did is it set the standard PC architecture. We still use that, I called it the 8086. That's abbreviated because there were later models of it, right? 286, 386, 486. Then they didn't go 586. They called it Pentium, right? And then they started going i3, i5, i9, i7, yeah, all that stuff. But the important thing is the 8086/x86 defines the architecture for 90% of the world's computers today. It's called the x86 architecture, right? Any computer with an Intel microprocessor is running the x86 instruction set. And that includes Macs. Oh, well, not the new Macs, the Intel Macs. Yeah.
The transition from room-sized computers to microprocessors led to the democratization of computing, the development of new industries, the creation of new technologies, the formation of a new global economy, and significant changes in society, economy, and culture. The innovation of the Intel 4004 in 1971 led to the deprecation of mechanical computation and room-sized computers and lifted us up into a new era of higher efficiency and faster processing that the previous computers of its time could never achieve. It has indelibly left its mark on the annals of history and the evolution of computing technology.